Welcome to Simplilearn's Python tutorial. My name is Richard Kirschner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to cover Python, one of today's highly utilized programming languages for its many diverse uses. I'll be working in Pycharm. Pycharm is put out by JetBrains. That's www.jetbrains.com/pycharm/ where you can download it. The benefits of using Pycharm is it creates an virtual environment, so you can change what version of Python you're using. You can make all kinds of alterations in there. For this tutorial, any Python IDE will work, but we'll be in the Pycharm setup. It is a really good setup to use on there. And again, you can download it here from the JetBrains website. So in the Pycharm environment, and if you're not using this, you'll need to follow whatever IDE setup you have for doing a new project. We've created a new project, and we're going to create a new Scratch file. This Scratch file we can call whatever it is we want. It's going to be a Python file since we're working in Python. We'll call it Scratch 3 Python. We can also rename this. You can see I have a number of other Scratch files. Delete them, remove them, whatever you need to do. So we're going to be working on our Python in this IDE. And again, whatever IDE you use will work just fine for this Python tutorial. And we're going to start with variables in Python, the most fundamental building block you need. Variables are entities of program that hold a value. X equals 100. The box is holding a variable would be the name given to the box. And if you studied basic algebra, x equals 3, x equals 100, it goes a little bit beyond just equaling numbers because we can also do words. But we're going to look at just variables. And let's go ahead and pull that up in our user interface and see what that programming looks like in the script language. So in Python, we can do something like print. This is a simple print statement, so whatever we put in here is printed back out. So we're going to put in here meet Jane, and let's also have it print Jane works as a software engineer. And then let's also do one more print line just so you can see what we're looking at. Print, and then we have Eli's is Jane's manager. And in here, you can run it a number of ways. We'll go underneath run. And here's our Alt-Shift F10 also does this. And it asks me, what do I want to run? I want to run the Scratch 3 because I have multiple Scratch files in there. And we'll click on there and it'll run it. If you're on like a different IDE, you might pop up with a black box that prints it out. And you can see here it says, meet Jane. Jane works as a software engineer. Elise is Jane's manager. You can always take that space out so it just looks nicer. So we have that. And it's kind of nice if you just want to print something out. And there certainly is a lot of times when you want to print the title of something. You might have your HTML code on the server and you print it out, and that's what people actually see. If they go to the Python and it accesses that Python code, it'll print out the HTML and it'll just be text printing it out. Now, this is all great. Let's go ahead and put a comment in here just so we can track what's going on. A comment uses the hashtag. So this just tells it this isn't code. This is just a comment for our notes while we're programming. And this over a little bit so you have better space on here. Instead of typing Jane, every time we can also store it as a variable. So let's go ahead and store that, and we'll call it name equals Jane. So now we have the variable name. And now we can do something like this. We can go print, there's our brackets, we want meet, and I'm just going to do a simple comma. Everything that's separated between commas, they'll print out in a row. So we have meet, and then we'll just do the name. And if I run this, you'll see meet Jane. Jane works as a software engineer. Elise is Jane's manager. And then it just says meet Jane because we replaced the name with Jane. And we'll take this off the top. I'm just going to delete that out of there so we can move on to this next setup with the variables. And we can also go print. This is kind of a cool system because I can now do string. We can hold a space for a string. Works as a software engineer. And then if you're going to put a placeholder in there, it has to know what the placeholder stands for. And this is one of the formatting options when you print something out. So we'll do something simple like this. We have a placeholder for a string, works as a software engineer, except the placeholder is supposed to be inside the brackets. And when we hit run, you'll see meet Jane, and then it also prints Jane works as a software engineer. You can see that right down here in the output, the terminal output from the run. So instead of having to type Jane over and over again, we can now put a placeholder in there and do the same thing with the last setup. Print Elise is, and there's our placeholder. the percentage sign and the S, and then we have name afterward. Let's go ahead and run that. And you can see here that we've now printed out the first one, meet Jane. And notice that this puts a little bit more, it has one space in here, but you don't really control the spacing on here. So when we do a formatting and we insert it as part of the format, you can see right here we put the name. It now has a nice format. Like I couldn't do this with a comma, but I can certainly do this down here with the apostrophe S for Elise is Jane's manager. And then we can also, instead of having Jane up here, maybe Jane got fired and May got hired. Well, let's just say there's a second employee named May. So now we have the name May in here, and I can run this, and you'll see it now prints meet May. May works as a software engineer. Elise is May's manager. So we've just swapped May in for Jane. And then one other important feature of Python variables is we could have name2 also equal to May. Keep the same name on there. And let's go ahead and print, we'll do ID of name, and then I also want to print the ID of name2. And what the ID does is the ID goes in there and says, hey, where is this name coming from? And let's go ahead and run that, and you'll see it actually gives us a memory address. And so one of the things that you find out about Python is to help save memory. Let me just swap this out here. In Python, variables with the same value hold the same memory space. So when we have name equals to May, name2 equals May, we print the idea of name and name2, and you'll see that they occupy the same memory space. Now, if we happen to swap one of these out, we'll do Jane again, and we run it, they now have two different memory spaces. So even though I make changes in here, this is one of the ways that Python's really good about saving memory in the computer. And the last thing we want to note here, which leads us into the next piece of programming, is that this is a string up here. Name equals Jane. So when we're talking about different data, we really have to also talk about different data types. And very specifically, we're going to look at numerical data. So when we talk about numeric data, talking numbers, the various types of numeric data are integer, float, and complex. There are in advanced programming additional numerical data types which have to do how it stores the data. But these three are the ones that you need to know about to get started in your scripting language and the most commonly used. And so an integer is just simply that. It's a number equals 5, and then if I print, and you can always find out what type of variable you have if you do a type on it. So we're going to print type number. And so if I run this, it comes out and it says class integer down here. So this is an integer number. And you can also do negative on these. So if I run -5, it's still a class integer, whether it's plus or minus. And the second most commonly used number is your float. And it's just like it sounds. If we have, let's do a number equals 5.6. And if you notice, I used the same variable name num on there. So I can actually take this and I can just copy this. And at some point we'll talk about ways of not having to recopy your code so you can create definitions. But let's go ahead and take a look at this. So we have our float. Our number now equals 5.6. And if we print the number type, we'll see that it is first an integer and then a float value. And let's do this just to number, just so you remember what we're looking at, number. And then finally, complex. So if we have a complex number, we'll go ahead, I'm going to keep number in there. Usually you don't leave it as number because then it confuses the code later on. But just for this particular piece of code, we're going to keep it number. And I'm going to do 5 plus 6j. And let's go ahead and print that out so we can see what these look like. And here's our number, comma, type number. And let's run this. And let's see what we got here. We have a 5, which is an integer, 5.6, which is a float. So it has a decimal place there. That's what the float stands for. So you're 5.6, 5.7, 5.8. And then we have 5 plus 6j is a complex number. And if you remember from math, complex number is based off of I squared equals -1, or the square root of -1 is that imaginary number. Now, I'll be honest with you, I don't use imaginary numbers much unless something comes up where I take a square root of a -1, and then I end up with a return of a complex number. So it's important to know it's there and know what it is when it comes up. And with anything, you do have to pay attention when you do conversions. So we can convert these things back and forth. And let's go ahead and put a little note here, conversions. And let's start by, let's just do, here's our print. And we'll go ahead and do our number, comma, type, back to what we were doing before, so we know what the type it is, and type number. So that's just from before on there. And let's say we want to convert it from a regular number to a float. And we can simply do something that looks like this. And let's go ahead and pull ways. There's our number, but I want to convert it. So I'm going to convert it to float. And then if we do that over here too, and I go float, that in brackets, So we're going to print this out, and if I run this, we now have 5 as a class integer, 5.0 is a float. So I've converted it to a float here. And we can also convert this to a complex, just like we did here with float. I can simply put in complex. And we'll do that over here also. Complex number, and if I run this, we now have 5 plus OJ. So this is a complex number. There's no actual negative imaginary numbers as part of it, so you're going to get just a 0 in the J part. So this is one way to convert it, and you convert it this way. We can also convert it back. So you can convert to in between any of these. And let's take our number, and let's make it worth 5.6. So if you remember correctly, this is now a float. And if we wanted to take that float value, print integer of our number, and then of course type integer of our number. And if we run this, we started off here with 5.6, so by default it automatically makes it a float value. And here we have it, we converted a float to a float, so it's not going to really do anything. And then we convert it to an integer. And look what happens as an integer. As an integer, it just truncates the 6 right off. So you got to be very careful when you're going the wrong direction on this. So if you're going from float to integer, you're going to lose a decimal value. If you're going from integer to float, which is a very common thing to do, especially with data science, you don't lose anything, you just gain the decimal place. So if we did it earlier, we had 5 became 5.0, and then you can see where it becomes a complex number. And we can do that just about any direction you want with the conversion. Python's really nice that it lets you do that, but you do have to be careful that you don't lose information that you need. So we've looked at variables, we've looked at numerical variables and how they differ. The next question is, what happens if you have a lot of data? You really can't just number 1, number 2, number 3. That's really not going to work in programming. So 3 of our basic lists is lists in Python. A list is a collection of data, and it can hold values of multiple data types. So you can see here we've set a value, a variable x, and we'll set it equal to 189a, hey, 0b. And it can store that in there. There's also the tuple. So we have list, tuple, and set. The tuple almost has the same format as the list, but instead we put the curved brackets around it. And what this means is a tuple is an immutable collection of heterogeneous data. Big mouthful there. What it means is once I set the tuple, I can't go in there and change one piece of it. As far as the tuple is concerned, that's one variable. Where a list is a list of subvariables, 189a, hey, 0b. A tuple, you can't change anything in here. Now you can access it the same way you do a list, but you can't make any changes on this tuple other than completely overriding it. And then finally there's a set. We put brackets around it. Now there's some other more complex data sets that go with this, that go above, or data type collections of data, but these are the 3 basics. And a set is an unordered collection of unique heterogeneous data. So it's unique. So if you put in 153 hey 6 Python and I try to add 6 in here, it'll only store one value of 6, since these are all unique in here. So let's jump into our IDE and let's create a list. Remember, it uses square brackets. That's how we denote that this is going to be a list. And let's just throw some numbers in there. 4, 5, 7, 5. So now I have a list. And we can do a simple thing like print the list. And if we run this, we'll see it come out down here as 1, 4, 5, 2, 7, 5. And one of the cool things about lists is that these are indexes. And this is kind of important to understand what the index means. So we'll go ahead and print list, and it always starts with 0. So if I run this and I print 0, it's going to print the 1, because that's in the 0 place. And if we print, here's our list, we print a 1 on there, and we run that, we have 4, because that's in the 1 place. So 0, 1, 2, 3, 4, 5. So there's 0 through 5. And this is interesting because if we print, let me go back up here to the top, I'm just going to print len, which stands for length of list. So this is going to return the length of the list, and I'm going to run this. And you'll see it says there's 6 things in there. But it starts at 0, so we reference them as 0 through 5. Now, if you're new to this, that can be confusing, especially when you're jumping back and forth in your code. So always remember this is point 0 through 5. It's not 1 through 6, it's 0 through 5, but there are 6 entities in the list. That's the length of the list. And we showed you here where you can access your 0 index, your 1 index. You can also access it from the right-hand side by simply adding a negative number in there. So if I add a -1, and I run this, helps if I actually put the list in front of it. There we go, run. You'll see that it points to the last one in the list. So -1 is the 5. This, again, a little confusing. You can't do a -0. So -1, going backwards, it starts at 1. And if I change the -1, say to 2, you'll see it'll go to the 7, prints the 7 out there. So we can do some very basic indexing and look at any one of these entities in the list. And then get the length of the list so we know how long our list is. Now, really common is not just to want one entity. Instead of wanting just one entity in here, let me just get rid of some of the notes here so that we can see what this looks like. I might want to access the first 4 values. So I can do print list 0, 4. And your first thought might be that we count this 0, 1, 2, 3, 4, which would be 5 entities, but we don't count the 4. So this is 0 to 3. So whenever you see this access from left to right, positive side, it's going to give us the first 4 elements. But it starts with 0. 0, 1, 2, 3, which is our 1, 4, 5, 2. And since we're starting from the beginning, you can always just leave the 0 out. And we can do something like this. And this gives us the same answer, whether you put the 0 in or leave the 0 out. It automatically assumes you're starting from the beginning of the list. Likewise, we can start from position 2 and go forward. And if you notice here, we get 5, 2, 7, 5. Position 2, if you look at this, we have 0, 1, 2. 2 points to the 5 position. So if you're going from left to right, you just say, hey, I want position 2, and you get everything to the end. And we could also put a second number in here like 4. That's just 2, 3, you get 2 values. Remember, it doesn't include the 4 on here. It does include the 2. Just like you can do indexes with negative numbers, I can now do -4. So this means that I'm starting with 0. I can leave it out. So the Python way is to leave it out. You don't need all that extra script. And it goes up to a -4. Well, where is -4? Here's 1, 2, 3, 4. So this should go up to this location, but not include it. And sure enough, we get 1, 4. So it goes up to -4. Remember, when you're reading it this way, from left to right, you don't include the -4. You include the first one, but not the second one. And you can also put the negative over on the other side and go -4. And if we run this one, now we get 5, 2, 7, 5. So we have 1, 2, 3, 4. And remember, it's on the left-hand side, so we include it. So we have 5, 2, 7, 5 coming out in the bottom. And the last really fun trick you can do, let me just take the -4 out, is I'm going to add a second colon here and a 2, and I'm going to run this. And it should print out every other one. So it goes 1, it skips 1. So it counts at 1, 2, 1, 2, and we get the 1, 5, and 7 coming out. And you can see that down here. And you can add in any of your other numbers in here. So we could start at 1 instead of at 0, and now you get 4, 2, 5. So again, we're skipping every other one, but now we're starting with the digit in the index number 1 place. Last thing to note is that these are all integers. If I put a 1.0 in and I run it, it's going to give me an error. It says I can't slice a float value. Even though it knows what 1 is, it needs to be an integer. And that's important to know if you're slicing your data into thirds. I don't know how many times I forget to do that, change it, convert it back to an integer, and it'll say, I can't slice 3.6666 or whatever it is. So remember to convert that into integers. So another thing to remember about lists, they can be mixed. So I can come in here, and instead of it being all, in this case we had all integers, I could easily put Python in here, and instead of 7, we'll do 7.4, 5. And if I print this out, let me just take that out of here. And by the way, this functionality of the index works identical no matter what's in your list. But we come in here and you'll see I have 1, 4, Python 2, 7.4, 5. And lists are mutable, so just like I did, just like I referenced the index, I can say list of, let's do 1, which is going to be the 4 place, equals, let's do hello. And if I print my list now, you'll see down below where it comes out, it goes from 1, 4, Python 2, 7.45 to 1, hello, Python 2, 7.45. And because these are mutable with the lists, we can also do something like list.append, and we can append Simplilearn. And now if I print my list out and I run this, you'll see that I've added Simplilearn to the end of the list. And if I do a link to the list, it's now gone from 6 to 7. Let's just do that real quick. Print length of list. So now it's 7. So we've added one more unit to the list. So they're very mutable, very flexible use of setting up lists. And then we can also take this list, let's do a new one, we'll call it nested. We can create nested lists. What that means is that here's my brackets to define that it's a list, and I can fill this with whatever objects I can think of. These can be anything, but we'll stick to numbers. I'll do 1, 2, and then I'm going to also create a nested list, and we'll create 2, 3, 4. So now I have a list within a list. So now we have a nested list. And if we print this, let's just print our nested list out. You'll see down below it prints it out just like I typed it. 1, 2, 2, 3, 4 is a nested inside the nested list. And then another option to append is we can also do nested extend. And we could go in here and let's create my nested loop. So I'm adding a nested loop to a nested loop. This is kind of interesting because you'll see here I have a sub list attached to the list, and I'm going to take the nested extend. I'm going to extend this on here. And if I run this, if I take this and run this, let me make sure I print the nested again. You can see how it's been transformed, and I got 1, 2, 2, 3, 4, and then it's added the 7, 8, 9 on there. Now, if I was just adding one nested list on here, I'd probably just append brackets around 7, 8, 9. But if you were adding multiple nested lists on here, you might do something. Then you want to use the extend on here. So we have 1, 2, sublist 2, 3, 4, sublist 7, 8, 9, and sublist 5, 6, 7. So I've added 2 different new nested lists onto this. So we've looked at lists. We've covered indexing of lists, we've covered appending or extending and sublists. Let's go ahead and talk about tuples, and tuples are really important. I'm amazed. When I first heard about them, I was like, why? Why have a list and why have a tuple? So the tuple is your curved brackets around, in this case we're going to do 1, 2, 3. And the most important thing to know about the tuple is I can't change it. I can't go in there and change the 1 to a 0. Now I can change tuple and have it equal something else, but I can't change the pieces of the tuple. And that's what's so important about the tuple on this. And you'll see when I print it, it also prints it with the curved brackets. So that lets me know that this is immutable. I cannot change the tuple. Now, we can access the tuple just like you did the list. I can print tuple position 1, and if I run that, it's going to print 2, because remember we start with 0, 1. I can do just the same way we did the indexing. I can do up to 1, which should print just the 1, because 0, and it doesn't include the 1. And there's our tuple comes out with 1 comma. So a little different output. You'll see this kind of notation when you're accessing slices of a tuple. And all the different functionality for indexing is the same. We can even do it in reverse. We didn't show you that on the list, but this works just as well on the list. Instead of the 2 for skipping, we can do a -1, and that just goes in reverse. So now I have a tuple of 3, 2, 1. So when I talk about it not being able to be changed, if we take and just get rid of the print for a second, and let's do this. Tuple of 1 is now going to equal 7. If I run this, it's going to throw an error because we cannot change the pieces of the tuple. I can reassign something else to TPL, my variable, but I can't change it. It's immutable. And one of the very common uses of a tuple is to use it as a key for something else. Now, we're not going to cover keys and codes in this tutorial, but imagine if you have an address to a house and the house is 123 Main Street and someone can just change that address. Then your house just kind of jumps all over the place. So you want that address to be unchangeable, immutable. And this is like a key code, so it's probably a key to some data. So it's a reference usually in some point, or it's some kind of data that needs to be set and unchanged when you set it for a tuple. And there's some other cool things we can do with a tuple. Now let's just take this one. We can do something, there's what they call packing and unpacking tuples. So just like we assign the tuple 1, 2, 3, I can also do tuple equals, we'll do 5, 6, 8, just because. And if I print tuple and we run that, it's still going to create a tuple out of it. And so we're saying, hey, this tuple is equal to these 3 values, whatever they are, and now this variable is equal to these 3 values, and it automatically converts it into a tuple if you do it that way. And we can unpack our tuple. I can do A, B, C equals tuple, and if we print A, B, C, run that, you'll see we get our 5, 6, 8 right back. So we can unpack it and pack it. You see this a lot when you're doing definitions in programming, where you're packing and unpacking the data. You'll get to the point when you're doing scripting, you don't really even notice or think about it until you're like, oh yeah, that is a tuple. Mind you on that one. But it does come up a lot. And then another strange thing I can do is I can do A star list. Now in this, list is a variable, and A is also our letter A, just from right above. And I'm going to set that equal to a tuple, and let's print that out. Let's print A, list. And if I run this, you'll see that I get 5, which is our A, and then it creates a list out of the remainder. So once I've pulled A out of the first part, I now have list in there. And I could have done A comma B comma C equals tuple. So this is straight from up above where we have A, B, C equals tuple. A comma star list just splits them up into two parts. The first part it refers to as just the value, and the second part it puts into a list, square brackets, so you can see how that's set up in there and how you can pull that information and manipulate it. And then finally we'll look at set, and you can create a set S equals, and usually you denote it with the squiggly brackets, and 1, 2, 3, 4, 5. And if you look at this, if you remember, the set should not repeat any values. So if I print set and I run this, I now get 1, 3, 4, 5, and I've got rid of all my duplicate 3's. So I can only have unique values in a set. And if we're looking at this, this is also a subgroup of a tuple. So that means that if I do S of 1, and I try to change one of the members in there equals 1, so I'm trying to change position 1, which is a 3 to a 1, and I run that, it's going to give me an error. I can't change it, I can't append to it, so it's just like a tuple. I can't change these values in the set. What I can do is I can take a list, and let's just change this. We'll go list equals, we'll change these to square brackets. So now I have my standard list. And we'll do a list down here, print our list, and then I'm going to print, and we'll use the keyword set, and we're going to change this from a list to a set. And then I'll go ahead and print that out. And if I run this, you'll see that my list has all the values, but the second I convert it to a set, which is a special kind of tuple that doesn't let you repeat values, you'll see that it gets rid of all my duplicates. So now I have 1, 3, 4, 5 in there in my set. So now we've looked at a lot of different ways to store our data in different variables. We have our list variable, we had our basic variables, we had our tuple, we showed you how to do a set. Let's start doing something with this information. We'll start with arithmetic operators, the most basic ones, plus, minus, divide. And let's just take a look and see what that looks like. And we'll need some variables to play with so we can look through the basics. And if you remember, we did A comma B equals, or B equals A comma B and all that. We can actually do A comma B equals 10 comma 5. And that's nothing more than what we already did, just a little different formatting. What I'm saying is the A equals the 10, the B equals the 5. That's all that is. And I could write that out, A equals 10, B equals 5 just as easily. And our basic arithmetic operators, you're going to see is we have A plus B. And we'll do this, control copy, put a bracket around it. So we have our A plus B set up on here, and if we run this, we should get what we expect. A plus B, 10 plus 5 equals 15. And we can do that all kinds of different ways. In fact, if we look at all the basic operators, let me just do it. No, let's keep it this way. We can take this, and we have instead of A plus B, we'll do A minus B. And let me grab that and put that over here. And let me just go down this and do them all in one shot. There we go. Paste them right in there. And most of these should be pretty familiar. The first four are your A plus B, A minus B, A times B, A divided by B. And so when we look at that, we get A plus B is 15, A minus B is 5, 10 minus 5 is 5. Multiply them, we get 50. A divided by B gives us 2.0. And now we get kind of an unusual one. We have A /B2. What this is saying is that if there's a remainder, let's just convert it to an integer. Remember I was telling you earlier I sometimes have to slice my data, so into thirds. Instead of going length divided by 3, I could do length / over 3, and that gives me an integer. And it just tells me, hey, where's my first third of data in? Where's that at? But if you do that, you also want to know what the remainder is. So that's what the ampersand is A, or percentage sign. That's what the percentage sign is, A percentage sign B equals 0. And then finally you can square it. And whoops, I forgot to put that as a 2. Data science, you tend to do a lot of squaring. You do like the square means error, so it's very common to see something to the power of 2. And so you'll see that A times 2 gives you your squared value. This is actually B squared. Okay, it's 25. 5 times 5 is 25. So these are your basic arithmetic operators. There should really, with the first 4, there's no surprises. You just have a surprise here when you do a double slash because it returns the integer and just drops the decimal. When you have the percentage sign, it gives you just the return value, so 5.5 comes back as 0.5. And then you have the double star is your squared, so b double star 2 is squaring your value. And we can take any of these functions and assign them. So I could do res as my variable equals a plus b, and then res now becomes equal to a plus b, which should be 15 when I run it. And sure enough, there's my 15. So now I can take a and b, and they might come in from all kinds of different areas, and set another variable that goes out to whoever needs it, returns it to the other part of the program as res. And again, this is true whether we do a plus b, a times b, a divided by b. Any of those basic functions is going to give us set the variable res to that. Now, we can also do what they call shorthand for a lot of this. So we'll do count's the most common one. You do a count equals 0 because you want to know it runs a process, adds 1 to it, runs a process, adds 1 to it. So we could do count equals count plus 1. And then if I print count, you'll see right here we get count equals count plus 1. I get 1. 0 plus 1 is 1. I can also do, we'll just do it up here, count equals, but instead of putting the equals there, I'm going to put plus equals 1. And this means I take count, and I might as well put the count here and the plus sign. And we can run that, and you'll see it now equals 2. So I get count equals count plus 1. Count plus equals 1 is the same thing, so I've added another 1 to it, and now I have 2. And we can actually do this with anything. Any of the main, I could do count times equals, so itself times 1. And of course 1 times 1 is 1. So we'll do something a little bit more exciting, like 1 times 3, and I get 3. And we could do this instead of with count, let's do a. Divide equals 2, and let's print a. And if we run that, we get 5. So I've taken a, which is 10, I've divided it by 2, a divided by 2 is 10, and again, any of these operators that we just looked at, I can now do down here. You know, there's the integer version, we can do the percentage sign, run that, it has a 0 remainder, so that's what comes up with it. Maybe, remember I was doing thirds. If we do thirds, we can see I get a remainder of 1. If I do divide, a divided by 3, there's my 3.3333, very common, but then I can also do the double divide, and I get just my 3 out of there. So a, whatever your arithmetic operator goes here, equals 3 is the same as a equals a, whatever operator you put there in the 3. So we had our basic arithmetic operators. We want to look at relationship or relational operators. And whenever you think of relationship, think true-false. Is this true or is it false? And again, we can do our print. We'll go a comma b, just so we have it down here. Take this out to clear my palette a little bit there. And so we have our 10, 5, and then we can do a print a is greater than b. And if you're listening closely, I said think true, false. Is a greater than b? Is 10 greater than 5? And if we run that, we get true. And if you remember what we did with arithmetic and you wonder where I'm going with this, you'll see that we have all of our basic operators. We have a is greater than b, a is less than b, a is greater than or equal to b, a is greater than or is less than or equal to b, a equals b. Notice this double equal sign. A little different there, and then we have an asterisk on the bottom. So let's go ahead and run this, and you can see down here, is a greater than b true? Is a less than b? That's false. Is a greater than or equal to b? It's still going to be true. Is a less than or equal to b? Still going to be false. And then a double equal sign. Well, because the equal sign is used in Python to set variables and to set values, whenever you do a logic where you want to know if it's equal, you have to use the double equal sign. That's very important. And of course, is a equal to b? The answer is false. Remember, double equal sign. And then if you're going to have an equals, you should have a not equals. So here's our not, which is the exclamation point. And you can see that a is not equal to b equals true. So as we go through here, we have our logical, our basic relational operators, which are logic gates on here. And we can take this up a notch. And to do this, let me just go ahead and create a little bit of different data here. And in this case, I'm going to create an A1, B1, C1 equal to 10, 20, 30. And of course, we print those out. As you guessed it, that should be just those values individually. Let me take this, clear my palette a little bit, and run that. And you can see we get 10, 20, 30 down here. And if we pop up, this is where it kind of gets interesting, is we're going to print, we're going to use the same operators we were just using, but we're going to do C1 greater than A1. And we're going to add an extra logic in here. And C1 is greater than B1. So I'm asking, here's C1 equals 30. Is it greater than 10? And is it greater than 20? And if I run that, we get true, because that, it is. C1 is greater than A1, C1 is greater than B1. Now, what happens if we had A1 is greater than B1 and C1 is greater than B1? Well, if we run this, we're going to end up with false, because A1 is not greater than B1. But we can, instead of and, we can do or. So if I run this, we'll now get true, because C1 is still greater than B1. So there's our or value. And you could stack these. I could do A1 greater than B1 or C1 B1. You could end up with a very lengthy logic statement. At some point, you got to avoid that. You have to find another means to do that. But those are two basic ones, is and or, and then finally, not. So I can take any of these logic gates and I can change them from A1 is greater than B1 to not. A1's not greater than B1. So is A1 greater than B1? No. This would return false, but then we just reverse it with the not and it comes out as true. So let's go ahead and clear this, and we're going to look at a very complicated, I don't know if it's really complicated. We're going to touch upon what easily becomes a complicated subject, which is bitwise operators in Python. So you can imagine, let's just go back to, what is it? We had our AB 10 and 5. So let's go back there and pull that back in here. So we're going to have our two variables, AB 10 and 5, and we're going to look at bitwise operators. To understand the bitwise operator, let's go ahead and print binary of A. Go ahead and do the binary of B. And we're not going to dig too deep into this. I just want you to be aware of it for more advanced programming. And you'll see it comes out here. Here's the bit value, which is your 1010, and this would be all zeros up until there. That's what the 0B means. It's binary, and everything else on this side is 0. And this is the same thing. 5 is represented by 101. 10 is represented by 1010 in binary when you switch it over. So when we look at this binary switches, we're going to do that. We can go, let's do print A and B. So if we run this, we end up with 0. And that's kind of interesting, because how the heck do they get 0 out of that? This is 10, 10, and 101. Well, if you line this up, this one on the right-hand side lines up with the 0. So guess what? That's 0. We take this 0, we line it up with this 0, and guess what we get? We get 0. There's no and. It's not the same value. And we have 1 and 0. So we are doing a if this equals this, if this equals this, and if this equals this. We get print A, which prints out, what does it print out? 0, because none of them match. And we can do something like print A, and you use the up-down bar. And unless you do a lot of work with this, you almost always have to look it up if you're dealing with binary number or with shifts and things like that of where these decimal places are. And so we're going to do A or B. If we run that, we get 15. And if we print, let's just print this in binary so you can see what that looks like. So if we print A or B in binary, let's run that. So remember up here we got 0. I forgot to convert print. Let's try that again. Let's print this in binary. And if we print this in binary, you'll see now that it's an OR. So we have 1 or 1 equals 1. 0, 1, 0 or 1 equals 1. 1 or 0 equals 1. It gets kind of confusing there, but you can see where if either one has a 1 in its place, or it then comes out as 1, and so we get 1, 1, 1, 1. And it does turn out that when you print this out, it came out as 15. So if you do a binary OR statement on these two numbers, you get 15 on there. And we can do this, we can continue this down. There are exclusive, so we can do print, and we'll do this instead of A or B, we'll do an exclusive, which is your little tilde. We can run that, and it's going to return the same thing because this is exclusively 1. So if this had been 1, 1, 1, 1, and this had been 1, 0, 1, 0, we would have seen the 1, 0, 1, 0 come through on the exclusive, where the OR returns all 1s. And if you have exclusive, you can also have 1's complement. So this would be like negating your number. So we can do, we'll just do this binary, and this is the other squiggly of A, and we run that, and we'll see that this squiggly comes out as 1011, so it reverses it. It's a little different on this because we are looking at a 1's complement on there, so it changes your logic thinking on there, and unless you do a lot of work with it, it can really tie your brain in a knot. It's kind of fun to figure out if you play with it. And then finally we have a couple more cool things you can do this. We can do print, we can do what they call a shift. And I'll go ahead and put this in binary because it's really hard to make sense of it if you're not doing binary. And we can do shift 2. This shifts it to the left. So you can see right here, we've added 2 zeros on the right-hand side to our A, and we have the same number and just shifted it all to the left. And we can also shift it the other way. Shift it this way, and we can run that. And now we just shift it off, and these two just get bumped off, and we end up with the last 2 digits, the 1, 0, because we're shifting everything to the right. Whoops, I'm sorry. We dropped the 1, 0, did it backwards. Since we're shifting it to the right, we lose this 1, 0, and we end up with just this first 1, 0. And this is when you get into like a huge array of trues, false, yes, no, and you need to compare them, and you can do all kinds of cool things in here. Again, it's a very advanced logic when you're doing bitwise operators, but it's important to know they're there and understand what they are, so when it does come up, you know where to look for them. And finally, talking about logic, we'll need to go ahead and look at membership operators. Very useful thing to have. Let's just do a list equals, I will do 1, 2, back there. 1, 2, 3, 4, 5. So we have our basic list, and the question is, let's assign a variable x equals 2. And so let's go print x in list. And what do you think that's going to print? Is x in the list? Is 2 in there? And the answer is yes, so we get true. So it's going to print true in there. And you can remember, we can also add the not in there. Is x not in list? We run that, it equals false. And when we start looking later on here, or shortly at our if-else list and while list, you'll see where this comes in handy to get these true-false statements on here. And then we have identity operator. Clear our palette, identity operator. And this is, let's do x equals 10, y equals 10, and let's print x is y. And if we run this, we get true, because remember when Python points to the memory, it stores the 10 in the same place, and so x is y. And if we change this to y equals 12, it will now give us a false, because they're no longer equal. So you could also replace this with x. I don't do a lot of x is y. It does come up, so you need to be aware of it, but it's not, usually you just do x equals y, false. But x is y, I changed it to 12, so again false. And then you can also go in here, x is not y, so is y or is not y. And it's true, it is not y. So these are all the basic functions, arithmetic functions that you find with your Python install. What we're going to cover next is what happens if it's not in there. What happens if you have some more complicated math equations you need to run? Well, at that point you got to import math. So the import, it's important to know what the import is. If we have an external module to Python, so it's not part of the basic Python code, you import that module. And math is used so much that they have it bundled with the Python install, but by default it doesn't load into your IDE, into your user face, or into the program. So when you go to use math, you have to run the import on there. And let's just take a look and see what some of the stuff that math covers. Now I did a quick Bing search and it took me to Python. This is always nice because we have the actual version here, which version of Python you're in, the documentation, Python, and then we went to the math module. And in the math module we have ceiling, we have copy the sign, fabs, factorial, floor. Ceiling and floor are kind of interesting because it's just really from an external viewpoint it's rounding up or rounding down, but there's other things that go on behind the scenes that you might use this instead. And then here's our basic functions, and if you scroll down you can see it just covers all kinds of different things, like is it finite, is it infinite, is it a NaN, modify f, powers. So if we're going to do an exponential, we saw how to square a value, but if you wanted to do something to the third or the fourth, you have to import the math module to do that. And you can see here where we have exponential of 1, this is like exponential x minus 1, log x, all your log functions are in here. Square root, there's one that comes up a lot in data science if you're going to take the square means of a value for your error. Cosine, sines, tangents, all the different trigonometric functions. All this is in the math. And really, we're not going to cover all the different things you can do in math because that's its own domain. If you're working with degrees and radians or hyperbolic functions, there's just a lot in the math module, including mathematical constant e, Dow, infinite, nan, pi. There's your pi in there. So all this stuff is in your math module. And when we're in here, we can do something simple like print math pi. If I run this, it should give me the value of pi, which it does, 3.141, so on. Any of the functions in here. If you import math, you could import something like this. You could import another option. Let's say I wanted just the pi value, and we could do something like this. We could also do from math, so that tells it to go to the math module, import pi. If we do this, we don't need the math in front of it, so we're just importing the pi. And I can run this, and now you can see I have pi here. Same thing. And we can do all the functionality that you saw earlier. Let's go back to import math. And instead of pi, let's go ahead and do a variable. So we could put in x equals 9.5, and then from here, from our math, we could do, if you remember from the very top, they had the ceiling, which I said was the same as rounding it up. We could do print ceiling of x, and if I run this, it should give us 10. So ceiling is actually the nearest integer that's greater than 9.5. You could also do, again, there's like cosine, tangent, all of these functionalities are in your math module. Let's see what tangent looks like. 0.0753, there you go. And then there's a couple that I see regularly in the coding. One is power. So I could do x equals 9.5, y equals, we'll just stick to 3, and we can do x to the y, or x cubed, and we can see we get 857.375. I use the power when I'm trying to figure out how long it's going to take to run certain programs, especially when you're going through a lot of permutations. You might find yourself going, okay, I got 3 permutations, and each permutation has 3 different variations. Well, that's 3 to the 3, so if I run it once through, I can guess at the time it's going to run by doing 3 to the 3, and then I can just program it to guess what my time output is. Another one is, of course, square root. So we can do the square root of, that's another very common one, square root, especially in data science when you're computing the error. We can do the square root of x. So we can do the square root, SQRT of x. And if I run this, I'll print the square root. Again, data science, the square root means error. There's your square root. Factorials, that's another one of those things that come up. Probably not as much, but if we're doing the factorial, we'll do y this time and we run it. This is adding up all the numbers up to 3. So this is 1 plus 2 plus 3, and it equals 6. Again, those are just a few of the different mathematical functions you can do. And you can go over to Python and see the full slew of them on the website. So far we've looked at data types, storing data, math functions, so some things that you can do with the data that comes in. Let's go ahead and cover another area. We're going to go into input. And we'll look at this is a very basic way of inputting data. And more specifically, inline input. So this is not your Windows interface or Frames interface or Windows XY interface. And there is interfaces for Python, whether you're exporting it into an HTML or some other format that then feeds the data back into Python. There's a lot of different options there. But this specifically is just inline. And what that means is we need to find a way to get the data in. So we'll do name input. There's our input command. And then the first part is the prompt. This is what it's going to prompt you for. And it says enter your name. And we'll add the scoop, I like to call it, but backward slash. In this case, N, this stands for new line. That's what these two symbols next to each other is. And the backward slash is a escape key. So if you actually need to put a variable in with a backward slash, like I want enter slash your, let's do enter get your name. This will print a backward slash. And this will prompt us for our name. And if I hit enter, you'll see enter get your name. And when I click down here, type in Richard, which is my name, and hit enter, then it continues the code on there. And then we can do something with this. We can do print, and we'll do hi, comma, name. And remember with the print, this just simply prints whatever the first one is, comma, the second one, comma, and so on. And so I can now hit this in here. When I go down here, it prompts me for my name. Enter get your name. Maybe get's kind of a weird way of putting it. Hi, Richard. We'll change this from get to enter input. And we might continue on down here. So we'll go ahead and do input age. I will do age equals input. Enter your age. And we'll do that same backward slash n. And this time, instead of printing the age, we're going to enter in an integer. This is kind of a very important thing to know when you're doing line inputs. If I run this and we print type of the age, let's just go ahead and go through this. Enter Richard, and it's going to say, hi Richard, enter your age. We won't put down my real age. We'll say I'm a young 25. It's actually significantly less than my age. And this is interesting because it takes the input and it's a string. That's what this class string means. So whenever you do an input like this, it comes in as as a string. And that's important to know because if you're trying to add age to something, it's not going to come out you get an error. So I could do print age plus 5. Because age is a string, when I come in here and I just do this real quick, misspelled my name, type error. It must be string, not integer. So it's trying to add 5, which is an integer, to a string, which it can't do. So that's very important when you're coding. You start getting those kinds of errors. That's where they're coming from, is you got to make sure your two types match. And one way, you can convert it. I don't know if you remember from conversions, I can simply put integer age. We'll do integer age plus 1, just so you can see how it's different. And it will convert it to age, or to a number on here, to an integer. We enter in our name, we enter in our pretend age, and you'll see that it now is able to add 1 to that age because I've converted it to an integer. You got to be a little careful with this because you might have characters in there that aren't integer, in which case it'll give you an error at that point. Let's do 2 more things with this. Let's go ahead and print with a format. So we have name and age, and let's say we'll do first formatting, and we'll put in an S in there, is second formatted word, years old. And if you remember from the formatting, we can now take this, add our ampersand at the end, or a percentage, and then we put the 2 variables, name and age, in here, and then I can go ahead and run this. And if we run this, we enter, oops, got to click down here. If we run this, I can type in my name, type in my pretend age. If you said tuple, you've got that right. So you got to remember, I'm sending it as a tuple. That's what the curved brackets do to it. So now when we run this, it should give me a nice format on here, so it looks pretty. Sometimes that's really important because people are coming in, see this all the time instead of these nice forms that come up. We used to see it where I'd do prompts like this for people coming in. And we'll see that we get an error down here because D looks for a decimal. We have 2 strings. So we could do something like this, integer age. And now if I run it, I shouldn't have any errors on there. I should come in here, 25, and there we go. Richard is 25 years old. And so we did a couple things in here. We now have our formatting. We now have string versus decimals, what the D stands for. That's pretty much any number. And make sure we give it a number. So we have a setup on there. And you would probably want to double check their input if this was for a form fill out or something like that. Although this usually, I use this for small programs where I'm testing something out and I got to put a different input in each time. I don't use them very often, but it does come up. It does come up where you might need to test something out real quick or have a line input for a very long script you're running and they just need a simple line input. And one of the last things we can do on here is we can take this and let's say instead of enter input name, how about a word? And we're going to do on this word, if you remember from before, we had our indexes for our list. Well, a word of any kind is nothing more than a string of characters, and that string is stored in a list. So I can come in here and take name, and I can say, hey, I just want the first 4 letters of your name. Maybe that's what it is. And we'll print, we'll just keep it name. Maybe you're creating a username or a reference. I've seen this where they have passwords and things like that set to the first 4 letters. I hit enter, it's going to return rich, just the first 4 letters. And that's because this index works just like it does in a list. It's the same index, because it is a list. And before we move on to the next section, one more thing I want to note about input. A equals integer. If you remember correctly, we did a conversion where if you had the number in here, 3 a character, this converts it to an integer. It gives you an error if you put A in there. We can also do this as a single line. And this is very common in Python to try to bring stuff together. They call it the Python way. It just makes it a little easier to read. And so you can see right here, enter a multiple of, we'll do 5. In this case, this actually converts it. So if I go ahead and put in down here, print A, we run this, enter 5, we get 5, and if I type in the type of A, you will of course see that this of type integer. We'll just go ahead and run this real quick. Print 5, class integer. So this is just a way of combining the conversion with the input. You can put it all in one line like this. Make it nice and compact. So what we want to cover next is the if statements. And there's like the if, the else, the elif. We're also going to start into the loops. We're going to cover the while statement, which uses the logic gate in the loop. And then we'll look at the for statement, which is just a loop without logic. And of course, there's a couple of odds and ends, break and continue, which go with the loops. So the if statement, this is where we start doing something with the data we're putting in. So you'll see here, I went ahead and did input, enter multiple of 5. And maybe we want to know if it is a multiple of 5. So if A, how can we do that? We can do A divided by 5 and get the remainder off of that. is not equal to 0. So just a little simple logic there. This returns true false. If remember, we covered all that true false statements. So if it's not equal to 0, then it doesn't, then if it's equal to 0, it has no remainder, so it's a multiple of 5. If it's not equal to 0, it has a remainder, which means that it is then not a multiple of 5. And we can just simply have it print. And we'll just, we'll do this. We'll go a comma, not a multiple of 5. And if I run this and I enter in, and let's just enter in 3, 3, not a multiple of 5. And if we have another piece of code down here, we'll just print, this is what happens next. So we might have some more script down here. And if we run that, we enter in 5, it just goes right down to this is what happens next. And if we go back and we put in 4, you'll see that 4 comes up and says 4 is not a multiple of 5. This is what happens next. And so the if statement only runs if this is true. And it runs whatever is indented. So here's our colon, and here's our indent. Python's very big on the indents. That's how it tells what piece of code is different from the next. Other languages use different, like a semicolon for Java. If you're in HTML, you have to put a block at the beginning, at the end. So every different scripting language has its own setup. And this is how Python does it. You do an indent right there. So make sure you're very careful where your indents are. And then let's go ahead and just do enter number. And if you can do an if statement, we can also have else statement. And the else occurs print a. So if I wanted to know if this is even or odd, we could do this. So I could do if a divided by 2, the remainder of that is not equal to 0, then this is going to be what? Odd. So this is an odd number. This is an even number. Just some basic logic there. And if we run this, I can now come down here, enter in 4. It says 4 is an even number, and then this is what happens next. And we can also do this if I enter in a 5. 5, this is an odd number. So just some basic logic. So you can see right here, either it is even, either it is odd, the remainder is not equal to 2, else whatever's next. And the only other option is it's even. Now this might be good if you're just doing a simple, you have 2 choices. We can also do the elif statement. And we put that in before the else statement, elif. And then of course we have our logic here. And we'll go ahead and combine some logic. We're going to do a couple things here. Let's go back up to this. Enter a number A, copy, and enter a number. We'll have a number A, B, and C. So we'll go ahead and have 3 different choices. Take out this last line. And so the first choice we want to know is A the greatest value? So we could do A is greater than B, and A is greater than C. So if A is greater than A and A is greater than B, A is the greatest number. So we have this over here, and if we have that, we can have elif. We can do, let's say B. B is greater than A, and B is greater than C. We'll go ahead and do this. We'll do a print statement, print B. B is the greatest number. And if A is not the greatest number and B is not the greatest number, that leaves one other option. So we'll go down to our else statement, and we'll have else C is the greatest number. And if we run this code, here we enter a number, we'll enter 1, 2, 3, and it says 3 is the greatest number. And of course, if we run this code again, we could do 3, 2, 1. And it gives me an error because I accidentally hit a character string there. 3 to 32, 2. So if we do this and we do 3, 2, 1, we still get 3 as the greatest number. And finally, we could put it right in the middle and it should still pull it out. We could do 1, 3, 2, and it'll still come up with 3 as the greatest number. You can actually go take this as far as you want. So we have just here the 3 choices. You could have if, else. There are other ways to do that when you get more than here. But for basic Python, this covers most of the program you're doing with the else and the else if statement as far as the logic statements involved in there. The last thing we want to really look at is a nested if and else statement. And we can do that. We'll get rid of some of this stuff on the screen, clear our screen here. And what we can do is we can go enter, let's do enter your age. And we'll call the variable age up here. So we're going to enter the age, and we want to know, let's say this is, are you available for a certain discount? Maybe it's a bus fare discount, maybe it's, you get a discount for a restaurant or something like that. So we have it here where you enter your age. And if A, let's do A is greater than 64. So if A is greater than 64, we put our colon in there, and this is actually age. Print, I will print you are eligible for senior citizen discount. And maybe we'll be a little nice, we'll make it if you're greater than 60. How about greater than or equal to 60? We're really feeling generous. So if your age is greater than or equal to 60, you get a discount. Else, we'll print you are not eligible for a discount. We'll go ahead and just run this real quick. And so if you are 66, it'll come up you are eligible for a discount. And if you put in 40, it will say you are not eligible for a discount. And then we come along, we realize, oh hey, we have a discount also for people who are under a certain age. We have our youth discount. So we'll go ahead and come in here and we'll say, oh, if your age is less than 18, let's do less than or equal than 18. Less than or equal to 18. Print. And then of course we can do, see, you are eligible for a minor discount or youth discount. And then we need to come up here if we want to do this. If age is less than 18, since it's nested, we'll do an else here. And if I put the else down here, a couple things to notice about this list. So we have our first statement. If age is greater than or equal to 60, you're eligible for a senior citizen discount. And then we put the else. So any logic, whatever happens under this else, this is always going to go. If I move this else back out, it'll give me an error because you can't have two else states. And certainly you could do this as an elif statement here too. So this is kind of another way of doing an elif statement. Sometimes you want to add some, let's put a note here. Sometimes you might have additional script here. So before you can do these two calculations, you might have to do some kind of calculation here. That's why you want to do a nested if and else statement instead of using the if, elif, and else statement. And we can see here, if I run this, enter your age. Now if you enter the age 9, you are eligible for a minor discount. And of course, what we did before, if we have somebody who's 56, you are not eligible for any discount. And of course, if you're 64 or 60 or older, you get that nice senior citizen discount. And if you were listening to earlier, no, I don't qualify for the senior citizen discount quite yet, although I do look forward to it. The next thing we want to start covering is our loops. And we have the while and for loop. And so the while loop utilizes your logic to let it know when to, how many times to loop through. Let's go ahead and take a look and see what that script comes out as. What we can do is let's go ahead and take a word equals to, let's do Python, since that's what we're programming in. And let's do I equals 0. And let's say while I is less than or equal to 5. And since this is, we use that indent, just like we did the if-else statement, we still need that indent in the colon there. While I is less than or equal to 5, let's go ahead and print word. And then we're going to do I. If you remember correctly, we're going to increment it by 1. We can do a plus equals 1. Same as I equals I plus 1. So I plus equals 1. And if we run this, we'll come down here, and you'll see it repeats the Python, in this case 5 times. And we can even do something like this. Let's do I comma word. And let's run that. And you'll see we get 0, 1, 2, 3, 4, 5. One of the things always to be aware of is we did I is less than or equal to 5. If this was an actual length of the array, you would have array out of bounds, because remember, you don't want to include the length of the array because it's 0 to 4. So a lot of times, just remember, unless you actually wanted to print 0 through 5, we can do while I is less than 5, print I plus or equals 1, and then we get our 0, 1, 2, 3, 4 Python. Now, there's other ways to do a loop like this, and I'll show you in just a minute with the for loop. This just gives you an idea. Here's our true-false statements, and just like we did before, you could have if I is less than 5, or I is less than 8, which would kind of be redundant. But you could have your or and you could have a very lengthy logic gate right here, as long as it returns true or false. So we use the while because we don't know how many loops we want to go through on here. In this case, we actually set it to 5. But maybe we're building a list, and let's just go ahead and do this. We'll do a list. We'll create an empty list. Let's get an input, and we'll call it C, and it says enter 1 to add elements to list and 0 to exit loop, the while loop. We've created a variable and then an enter here. And the input, if you remember correctly, we're not converting this to an integer. So we're going to just go ahead and keep it as a character. And so we're going to say while C does not equal, and because it's a character, we got to go ahead and put the brackets around it to let it know it's going to be a string, the string of 0. So long as this doesn't equal 0, keep doing. And then what we're going to do here on our while loop is we're going to have another input here. And on here we're going to have input, enter an element to add to the list. Let's see, input, integer, this one isn't it, we'll just keep it as a straight input. I kind of like that. Keep it uniform on there. And what we can do, let me just go ahead and copy this up here. So we're going to start adding elements. And the order in which we do this is always important. You never know how your loop's going to go. I switched that around because I want to append to my list C. So whatever we enter in on the first one gets appended to the list, and then we ask for the next one. If the next one is a 0, so whatever we type in there is going to be added to the element. And the order, as I was saying, is important because if we put this after the second input, whatever you put in here is going to ignore. And if we put it before, then it's going to keep adding it in until you put 0 in. The 0, if you put this after the 0, it will still add the 0 in. So you'll end up with the 0 at the end of the list. So by putting it before this input, we're going to have both the first input going in and whatever input we add in. And to get a view of what this looks like, let's go ahead and print our list. When we run that, you'll see it comes up. It says enter 0 to quit and other to add to list. But I can add an A in, we can add a 3 in, a T. Remember, I didn't put any bounds on it, making it an integer or anything like that. And I'll put the 0. And when I put the 0, there it is, A, 3, and T. So this while loop keeps going until it hits something that says, okay, we're done, and then it just kicks it out. So it finishes the loop, comes back up here, says, is this true? If it's true, we do it again. If it's false, then we skip out of the loop. And then it continues on down below where we printed the list. Now, if you remember from earlier when we had the I+1 and we just looped through to print Python out 4 times, certainly there's better ways to do that instead of adding all that math in there. And we can do that. So word equals, let's do Python. So we can do that just simply by doing a for loop. For doesn't require logic. We do for. We'll do W in range 10. And let's go ahead and print W, comma, word. And if I run this, we'll see we have Python printed 10 times. Let me just take that down a notch since my screen display doesn't show up as much. So range 3. And if you remember from earlier, range does 0 to 3 but doesn't include 3. I could just as easily put 0, comma, 3 in here and I'll get the same answer. And you can also add a step on there. There's a lot of controls you can add with range. So we can print W, range of 3. And that's pretty cool. It just prints word over and over and over again. What we can also do with this is we can create a list. So I can create my list. There's our square brackets. And we could do 1, 2, let's add hello. We'll add a sublist, which is 1, 2, 3. And so we can do on this is I could do, instead of a range, I could do object in list. So for object in list, I want to print just the object. And if we run this, you'll see down here we have 1, 2, hello, and then it printed the sublist, the whole sublist in there, 1, 2, 3, because that's one object in there. So it just iterates through each entity in the list and prints it right out. What we can do next is we can kind of combine some of these. So you've seen the for loop, we have our if statements along with some different logic gates we can do. So we can do, let's do this. Let's go word equals input and let's do enter word. So we're going to get a word from you off of your keyboard. Let's do count equals 0. And we're just going to count vowels. We're going to use the loop to count the number of vowels in word. So for I in word, remember from before, we can iterate through each object. And when you do a string, so if we have, if our word was equal Python, we have Python. Each one of those is an object in that list. That's an actual list. So when we enter the word, that's a list of letters. And so this is just going to go through and look at each one of those letters. And we're going to say, hey, if I in, and we'll give it an array. If it's A, E, I, O, U, or capital A, capital E, capital I, capital O, capital U, these are seen differently. They're very different characters on there. We have our colon here. This lets us know we need to indent. At this point, we know it's a vowel. So we want to go ahead and count plus equals 1. And then we just want to go down here and say print number of vowels in, let's do a little formatting. S is D. If you remember, we got to create that little tuple at the end with all those different values. And so here is our word and our count. So let's go ahead and run this. And for the word, I'll go ahead and enter in count. And we can see the number of vowels in count is 2. And sure enough, it's got an OU in it. And if we run this again and let's do counting, we can see that there's 3 vowels in there, OU and I. Now, when we're talking about loops, both the while loop and the for loop, and this works actually on the continue and break will work any kind of indent. So even the if statement, I could add a break partway through the if statement and it will kick it out. So that's important to know, but we want to know about break and continue and how those work. So let's go ahead and create a little script here so we can take a look at it. And break is just like you think it is. Whatever it's doing, it stops it. It breaks the flow. So let's go ahead and do this. We're going to do range 2, comma, the integer of n divided by 2 plus 1. We're going to look for a prime numbers. We're going to see if we can figure out how to find a prime number. And so what we have going here is I'm going to take n, which equals 49, and to help me find the prime number, we're going to go all the way through, let's see, in range 2 to n divided by 2. And we're going to add 1 to it. Now for the first part, we don't really need to add the 1, but I'm going to show you in a minute that for another piece of code we can put the 1 in, so I'm just going to leave that in there. And we're going to just divide by each of those i's. So I is equal to 2, 3, 4, 5, 6, all the way up to 25. So it's basically 2 to 25. And we want to take and we want to divide by that, but we want to know if there's a remainder. That's how we can tell if it's a prime number, because if it has no remainder, then we have a prime number. So n divided by I, the remainder of it, if that equals 0, then this is not a prime number. So we'll print this is not a prime number. And instead of this is, we'll just go ahead and do, let's just do something simple. N is not a prime number. There we go. Now, if we picked a number like 20, it'll get to 4 and print this is not a prime number. It'll get to 5, this is not a prime number. It will get to 10, this is not a prime number. It's going to print that 3 times. We don't want it to keep printing that. We want it to stop. We want to say, hey, we got an answer, it's not a prime number, break. And if we go ahead and run this, we should get 49 is not a prime number. It's divisible by 7. We do know that, the number 11 is a prime number. So if I run this, it'll just go through the code and say, okay, we're good. This is the kind of thing you might do if you have an input and you're checking the input to make sure they're valid inputs. You want to come up and say, hey, this isn't a valid input, kick it out. Or if it's a valid input, go ahead and do the process on there. And if you're going to have break, we also need to look at continue and how that works. And so let's say instead of looking for a prime number, I want to know all the different numbers that divide into the number. I want to know what it's divisible by. And so we can do that. Let's do if it's not equal to, if n divided by I is not equal to 0, I want it to continue. Else, what I want to do is I want to print, let's do our place marker. We'll do D is divisible by, this is also going to be a number, so we'll do another D for decimal. And then of course if you do this part, we got to have our tuple on the end, and in this case we want to do our number n is divisible by our number I. So let's take a look and see what's going on with this code. Continue, unlike just says, hey, here we have our loop, or it could be a while statement, for statement. So here we have our loop. I get to here and it says, okay, if this remainder does not equal 0, I don't want to do anything after this. I just want to go back to the top of the loop. And so it skips this line down here. It's like an else statement right here. Else, do this. So this is one way you can almost put an else statement here instead. So I can run this and it says process finished, because 11 happens to be a prime number. We'll set it to 20 since I brought up that earlier, and we'll see that 20 is divisible by 2, it's divisible by 4, it's divisible by 5, and by 10. It just goes right down the list. And so this gives you an idea of how you can utilize the continue when you're in one of these loops to use that logic to help you get the script to do what you want it to do. The next topic we want to cover is going to be some more advanced modules. As you get more and more advanced in Python, you really are starting to look at all these great modules that are developed by third parties. One of the greatest strengths in Python is you get a module to do almost anything. And 2 of the modules we want to look at are arrays and NumPy. These are, in data science, they're so important for storing information and manipulating it. And the difference between an array, because remember we did lists, remember lists from before, or list, they equal within the brackets. And a lot of times you might have caught me once or twice, hopefully you didn't, but you probably did, where I called a list an array. In Python, they're not the same thing. That's very important to note, because a list is a base Python list of objects, where the array is a special module you bring in. And you got to be careful when you're talking about other programming languages. An array is what a list is in Python. So you might hear that terminology. They probably have some other programming languages. And they do have a lot of similarities. So we're going to do from array import star. So we're going to import everything we have from the array setup. That's all this means. So from our array, we're importing all the different submodules in it. You could probably just get by with import array at this point, because that would do a similar thing, but we want to let you know that there is a difference there. And when we do an array, we just use the array command code, and then we can create the array inside the brackets. And just like a list, we can do all kinds of things with this as far as mix and match. But one of the nice things about array, I can also tell it has to be of a specific type. So in this array here, I'm designating these are all integers. Send to it a list of integers, 1, 2, 3, 4, 5. And if we print the type of the array, you should see it come down here and it says, okay, class array has finished. So the class is always going to be an array on here. And this particular array might designate it as integers. We can also do on our print, just like you have, like your regular array, you can access the integers by their index number. So we'll put in 2. If we print the array of index 2, we'll see that it points to 3. So it's just like a list so far. So far, it has all the different setups you would as a list on here. And this includes append. So I could actually take this and I could go array append -10. We'll run that. Just print out the whole array. And we'll see now we have an array of type I, 1, 2, 3, 4, 5, -10. So we can just append just like we did. So in other words, all the functionality you have on your list, you're going to find you have with the array. We'll just go ahead and do a couple more like that so you can see what that looks like. Let's go ahead and remove 3. So if I remove the value 3 from here, you'll see 1, 2, 4, 5, -10. If we want to go ahead and print, you saw I printed the index the first time. We can also do an actual index -10 on the array. Let's go ahead and run that. And we get 4. And this is kind of interesting because if I did this with a list, I would get an error by doing the index -10. So we have -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it just kind of loops over till it gets to the 3. But where arrays are different than lists, and this is so important, this is what makes an array an array. We'll take this back here and just print the array on here. I can do something like this. AR equals AR times 3. And if I run this, you'll see right here, my array has now jumped. And so when I do AR times 3, the array is now 2, 4, 5, -10, and it repeats it 3 times. So this is one of the cool things you can do with an array on here. Now, at this point, if you're doing a lot of functionality on your array, you'll almost always end up in numbers Python. So even though there's a lot of really cool things, especially the type settings, so that you can actually have it all integers, really, in this particular module, you want numpy, which sits on top of array. And probably the most common form you see it, you'll see import numpy as np. Now you can just do import numpy, and wherever you see np, you use numpy. Now, if you are, you'll see when I run this, I get an error because I opened up a new project in Pycharm. That means all my modules that are added in externally aren't there. If you are working in a different IDE, you might go to the command line and do a pip install numpy. And that will bring it in if you're using pip. There's a number of different install packages. If you're using Jupyter Notebooks under Conda or Anaconda, it's Conda install. Conda does the same thing as pip, except that it brings in all the different sub-packages. Pip's the most common one, your pip install. But we're in Python Pycharm. And so in Pycharm, we want to go up to, click on that file. Once we're on file, we want to go down to settings. Once we're under settings, we want to go under our project, and then you'll see project interpreter. This is really cool that we're actually in here because you can see underneath here we're using Python 3.6. So if I had a rollout in a different version, I could go in here and add those versions in and switch them around. I just have the one on this particular machine. And I go over here to the plus sign on the right hand side, and I click on there, and then for installing in here, we'll type in numpy. And once I have numpy, you'll see there's different versions of numpy on here. Generally Generally, you want to ignore all of those unless you're doing something special and go right to the one that's just straight NumPy, and then click on Install Package. Then Pycharm will take over. It will install the NumPy package into this particular environment. This is one of the beautiful things about using Pycharm is it keeps this environment separate from everything else. And then once it's installed, we can now go back, close out of here, out of settings, and there's our NumPy added in there, so now it shows me what I have installed on here. This is such a great tool because I can see exactly what I'm using in this environment. And now when I run it, you'll see I don't get an error for not having the module. So you got to make sure the NumPy module is installed. And this really is, if you're doing data science, one of the bread and butter tools you need is your NumPy setup, your NumPy array. And we'll go ahead and create our first NumPy array. We'll call it AR1 equals np.array. So np for NumPy, .array is the command. Oh, let's just do 1, 2, 3. I guess I'm being a little boring as far as what I'm putting in it. And then let's go ahead and just print that and see what that looks like. Print. And this is an array made with a list. There's other ways to make an array, but we're just going to print our AR1. And we put a list in there. So we just designate a list into it, and then we print our AR1, and we see that it comes out. It looks just like a list. One of the catches is there's no commas in here. So if I wanted to go ahead and let's say take our list, and you're going to say, why is this so important? There's no commas in there. If you're doing a lot of debugging and you see this first one, you know you're either in an array or a list. If you see the next one, you know you're in NumPy. So it's just kind of a quick flag in the programming script and debugging for some of the things you can look for. Now, the NumPy array starts to take a major shift here. This is where this becomes real important as far as the setup. We'll talk about shape and sizes and matrices here in just a second. But let's go ahead and do this. We're going to create two sublists. So remember that from before, we have list 1, list 2. If I'm going to do that, I do need to put brackets around it. This is a 2D sample, and you could look at this as being one of the common things is X, Y coordinates. So I might have 1, 2, 3 for X, 4, 5, 6 for Y. And if we print that out, you can see as it comes down here, print our AR1, it prints it out, no commas, but you have your two different lists on here. And we can do something like this. We can print dimensions equals, and then I'm going to do AR2.inDimensions. So if we run this, you'll see it comes out with, I have it print our setup on there, and it has 2 dimensions. And that's pretty easy to see. We have dimension 1, which is a 1, 2, 3, and dimension 2, which is 4, 5, 6. Likewise, there's also size and shape. And so if I do this setup on here, we can see that we can get the size, dimensions is 2, the size is 6, just how many entities are in there. And then the shape, this is, I don't know how many times I look at the shape of these things, because you're putting it through some kind of format, and if your shapes don't match when you're doing machine learning and you're doing a fit and a train, you'll get an error. And so it's so important to double check your shape and make sure it's correct. Make sure we have a 2x3 matrix in this case. And then finally, just like you can do this with any of type command, we can also get the what they call D type in NumPy. So in your number array, we'll see that the type of elements is an integer 32. So it actually returns what kind of elements I have in here. And they do. They all look like integers on there. Let's go ahead and take a short detour here and just take a look at the NumPy official site. So if we go to the official NumPy site, we'll see right off the top scipy.org, which is the group behind it. It's all open source. You can actually go in here and donate to it. And it is so extensive. I'm just going to look at data types. And so data types gets its own tab, and you can see from here we were integer. There's so many specialties you can do with this, and so they cover just about every data type you can think of. There's our integer 32. So here's our integer 32 that is the standard. That's usually what it converts to if you're converting directly from Python into NumPy. But you can force it into any of these other different kind of data types on here. So it has a lot of diverse use on this. Obviously, we can't cover everything under NumPy. There's array creation, input-output with NumPy, indexing, broadcasting, byte swapping, structured arrays. Each one of these is a significantly large topic. It's its own class, if you will. You can see right here we're going to do that. We'll try to cover just a couple things so you get a little flavor of NumPy. So let's take a look at, we have our NumPy stuff going on. Let's go ahead and look at filling an array with zeros. This comes up because sometimes you want 0 as your placeholder, and so you begin your process with filling it with zeros or ones or other values. And you can simply do np.zeros, And then this is important, is it needs to know the dimensions. We'll do a 2 by 2, and we'll do a d type equals, and there's our integer. So we're going to fill it as integers on here. Let's go ahead and take our z, and if we print this out and run that, you'll see that I get a nice 2 by 2 array filled with 0. So maybe I'm doing plotting. I don't know what the plots are, but I need to have it pre-filled. Yeah, a lot of test data does this. You can create your own data and make stuff up and do all kinds of things there once you have it pre-formatted. And if we fill it with zeros, we can also do fill it with almost anything. So instead of zeros, we'll do a full, and let's do 2, 3, and then instead of this, fill it with, let's do 1. And let's run this. And when I run this, you'll see that I've created a 2 by 3 array, all filled with 1s. And just like our list and everything else, we can come in here and we can access the different indexes of our NumPy array. In this case, we're going to do index 1, 2. And when I run that, we get 6. Where does 1, 2 come from? Well, remember, we count from 0. So there's 0, 1. And we count from 0, we get 0, 1, 2. And so if we do this arrangement, 1, 2 is going to be the row followed by the column. And just like any of these, we can get very complicated. We can do something like this. We'll keep this as 1. And we could also do, so we'll do 1. We have our comma, but I want to do after the comma a colon there. Then I'm going to put in another colon. And if you remember from before, that means we're going to do a step. And let's do -1. So this should look a little familiar. This is the same kind of format you got from list. And if I run this, we're going to look at the 1. So 0, 1, 4, 5, 6. I'm going to select all of them. That's what the first colon is. And then the second one says, hey, but I want to go backwards. We're going to step -1. And so we're going 6, 5, 4 on here. That's why you get the 6, 5, 4. And we could also do something like this. We could add in 2, 1. And if we run that, you'll see that I get 3, 2, 1, because it doesn't include 1. I could do up to 2, and then we get 3, 2, 1, 6, 5, 4. So now we have that the first 2 in reverse, 0 and 1. And you can just play with this. Different ways to select different entities in our NumPy array. And although we can't dig into all the different aspects of a NumPy array, I did want to bring up one last thing, which is operations on a NumPy array. This is pretty cool because I can take this, and here's our NumPy array we've created. We can do something like this. We can take print array 3, and let's just add 10 to it. And this is a little different than what we've seen before. So if I run this and I add 10 to it and we run it, you'll see it adds 10 to every entity in the array. So I have 11, 12, 13, 14, 15, 16, and so on. I'm just adding 10 on there. And likewise, I could do all kinds of different values like times 10. So they're just multiplied out by times 10. There is other functionality, like you can sum it. So we can sum all the values in there. You could also select just a slice of this. So you could select, let's do the first 0 and then sum it. And so we get 6. 1 plus 2 plus 3 is 6. So there's sum, there's min, there's max. The slew of commands just goes on and on and on. There's so much you can do with the NumPy array. And some important things to note, there's also what they call transpose. And this comes in a lot when you're graphing, because you might have a graph that looks at XY. Let's go back to our 2D array, and it wants all of XY, but your array came in as all the rows. So you have 1, 4, 2, 5, 3, 6, and you need to transpose it. If I run this, you'll see that I've gone from 1, 2, 3, 4, 5, 6 to 1, 4, 2, 5, 3, 6. It tends to be the other way around. There's times when you need the individual pairs, and of course we could go back and transpose it going the other way. Of course, this doesn't work because when you do this, it doesn't do it in place. You have to let it know it's in place if you're going to do that. So we'd have to do something more like AR3 equals AR transpose. Take this T out, and now we should get it where it flips it from the original values to 1, 4, 2, 5, 3, 6, and back again. So we can move the data back and forth and transpose that back and forth quite easily with this. So we touched a little bit upon the basics understanding of NumPy. It's a really powerful tool. We need to move on and look at functions. Functions are so important in Python. They're kind of programmers' bread and butter. So let's do a function. Just call this fun. And in our fun, I wanted to print Simplilearn. So what I'm doing is I'm creating a function that allows me to call this piece of script whenever I want. So instead of having the loop do this, I now have the function do this. And instead of, maybe I have this function where I want to print Simplilearn at 5 different places in my program. Instead of retyping it, I can just wrap it all up in a wrapper, function wrapper. And we can simply just call this, the way you call it is you just type in the name fun, because that's the name of our function. A little confusing there for fun. Simplilearn is fun. I like that kind of combination. And if we run this, you'll see it just simply prints Simplilearn, because this function executes whatever's in this indent. And you can see right here is our def, lets it know it's a definition, the name of our function, and then a set of brackets right here. Now, if we want to do something, it's exciting just to be able to print something, maybe we want to add 2 numbers. And let's go ahead and do A, comma, B. We can now put these numbers in these brackets, and this function now sees these numbers in here. And we can go ahead and print, let's just print A plus B. And I'm going to come down here and go add, and we'll do 4 comma 5. We'll run that. And if we run that, you see 4 plus 5 equals 9. Well, we might not want to just run it. We might want to actually have a value come out of it. And so instead, we'll do S for summation equals A plus B. And then I want to return this value. So now I can come over here and I can do, we'll just call N for number, equals add 4 comma 5. And if we print in, you'll see this whole process now brings it all together. So now I have my function, I'm sending it A comma B, it's going to add A comma B, and it's going to return the results for that, and then I get that under my in. So I set this variable equal to that, and I print in. And something I want to point out is that this return S is a tuple, and we'll talk about that again in just a minute. Or why not? We'll just go ahead and do that now. So we have our summation, and then we might have the difference. What's the difference between A minus B? Do minus B. And I'm going to leave this just as in so you can see what that looks like. But we're going to return S comma D, the difference, sum and difference. And if I print it out, you'll see that it returns 9, that's our S, and D is a minus 1, and it's in a tuple form. So S comma D returns this nice tuple. We can also, instead of doing this, I could do N1, comma, N2, and then we could print N1, comma, N2. And we did this earlier when we were assigning variables. It's the same thing, but instead of assigning this N1, comma, N2 equal to whatever they are, 9, comma, minus 1, we're having it return from our function. So it comes right out there, and then we can print the 2 different values. And then this is kind of an interesting thing. We can come up here and preset our values going in. And instead of A, I'm sending it 4 comma 5. I'm going to say A equals 1, B equals 3. Let's do this the other way around. Let's go 5. If I run this, now remember last time we sent it 4, 5, and I got 9 minus 1. Now I'm sending it 4, 5, and I still get the 9 minus 1. But if I take this out and I don't send it any values, it'll automatically default to the A equals 5 and B equals 3. And then we get our 8, 2. 5 plus 3 is 8. 5 minus 3 is 2. So we've covered a lot so far as the basic definition, sending it information, returns it as a tuple. One of the tricks you can do is a star args. They call them args and quarks. And we're going to talk a little bit about what the difference is between args and quarks. They are designated with the asterisks. So this is args. Now I don't have to call it args. I could call it my args. That is not specific to the program. And we can just go ahead and print. I always like to do lowercase for the first letter, and then when I change names, uppercase. And that's just kind of a Python standardization for naming your different variables. And if I print my args, we can come back down here and I can do, let's just call this AK for args and quarks. So let's spell it out. Args underscore. There we go. And so if I go down here and I go, hey, let's call my function, paste that down here, and we'll come in here and I'm going to put in 1, 2, 3, 4. It might be I don't know how many values I have going in. I just know that I have a bunch of values that are going to come in. And I know what order they're in. And so you can see right here, it takes my args, we print out my args, and I typed in 1, 2, 3, 4, and that's what comes in. And we could do something like this. We could print args of 1, because maybe that's a specific setup, and it'll print 2. 2's in the 1 place, that's our index. And if we're doing like addition, we could do something like C equals my args 0 minus, let's do addition, plus my args 1. And you can guess on here, if we return, call it a, we can come down here and do a equals args of quargs. And then if I print our a and I run this, you can see it comes up with 3, because 1 plus 2 equals 3. And it might be that you only do stuff if 3 and 4 exist. Let's just do it this way. Well, this is fine. So you can see right here that we can now send it whatever args I want, and it will do those in a list. So I could send significantly more values in here than is up here, and that's okay. And that's how your args work. Again, the asterisk. So where does quargs come in? What does kw args mean? Well, instead of my args, let's go star star. Let's go asterisk asterisk or star star my kw args. And let's just go ahead and take a look and see what these look like. Let's print them out. Grab this variable up here. And again, it's the double asterisk. This lets us know that this is a chord. And down here, where I'm calling my definition, I'm going to go ahead and change this up, and I'm going to say a equals 10 and b equals 20. And then we have return a. Let's just take the return a out for right now and just have it print it. And if I run this, you'll see it comes up with A10, B20. We haven't talked about dictionaries. We didn't cover dictionaries yet. It's a special kind of set. And the way the dictionary works is you have your index or key, and it has a value. And the index or key is immutable. You can't change it. You can delete it, you can add it, but you can't change it. And you can change the in value. And so you can see right here we have an index of A and an index of B. And so I could also do print my quarks, and instead of doing 0, I can now do A. And we'll do addition. We'll do plus my quarks of B. Hit the wrong button there. Okay, plus my quarks of B. And if we run this, of course you got to make sure this is a string. The A value here is definitely a string coming in. We can do print my quarks of A plus my quarks of B, and you can see that we get 10 plus 20 equals 30. So this is just a really cool way to send information to your function and have it be able to, like, you might have all kinds of stuff in here you need to send. Once you send it, you can do all your different processes. You can also do, if you remember from before, I can do something like this. Let's do this. If A in my quarks and B in my quarks, then print my quarks of A plus my quarks of B. And you can see right here, if I change this instead of to A, I could change it to C and run it, and it'll say, hey, I've got a value of C, I've got a value of B, but because A's not in there, I'm not going to do this addition. So you start to get into some logic gates that make sure you have the data you're processing in there and what you're working on. And then one last cool thing to remember is that our definition is an object. So like any other object, and we'll talk a little bit more about objects here in a minute, I can assign it to a variable. So I can do D equals my args quarks, and then I could do D of, I'll do A equals 1, comma B equals 2. And if I run this, I'll go and run that, you'll see our first run, which we already had up here, where A, C10, B20. And then you'll see I ran it again, and this time it has A equals 1, B equals 2, and it sums them together as 3. So you can assign this value, you can assign this whole definition to a variable. The final thing we want to touch upon with our definition and our functions is the recursive. We've already discussed the whole reason having a definition is I can now call it from multiple times from different parts of my program, so that if I know I need to add certain numbers together, I don't have to repaste this code in every time I need that. I just access my definition in a single line. So recursive means the program, this definition calls itself. And just like the while statement, you run the risk of running an indefinite loop. And of course, if you're stuck in an indefinite loop, that will eventually crash your program you're running. And so we might have, we'll call this definition rec for recursive, and we want to take in and we want to do something with it. So we might say, hey, if n equals 1, print in and return. So when we hit the value of 1 on n, we know this recursive function's done. That's what this is doing. But if it doesn't equal 1, we might want it to print in, and then we could do something like this, return recursive of n minus 1. So let's take a look and see what's going on here. The first thing it does is it says, hey, if n equals 1, we're done with this loop, because it is a loop. It's looping in on itself. And what we want to do is we want to go ahead and print in and then just return. And then we come down here and we say, well, if it's not equal to 1, we want to print in, and then we want to run this loop again with n minus 1. So we're changing our logic gate. Here's our n. N keeps changing. So n starts off at one value and we keep subtracting. And then we can just do something like this. Let's do our recursive, and we'll redo with 3. And we'll run this. And I get 3, 2, 1. Why? Because each time it goes down here and it subtracts 1, that goes back into this. Then it says, okay, 3 minus 1, is it equal to 1? No. Print it out. Once we printed it out, do n minus 1, and so on. And you can see right here, we just do a simple countdown. Certainly, there's more complicated scripts you can write, but you can see how this simple recursive value works. We could use this to solve a factorial problem. Let's call this factorial def fact of n. And we'll change this down here so we call it and run it. And if you remember, factorial is simply we take a value, we want to return, call this f. F equals 1 for I in range. Let's see, what would it be? In range of 1, comma n plus 1. Remember, it doesn't include the last one, so we have to add that extra plus 1 on there for our range. And we simply do f equals f. We can actually do this the Python way. F times equals I. So f equals f times I. And it just keeps going through and finds out what all the factorials are. And if we do this, return f, we can print our factorial of 3. There we go. And we run this, and we'll get a nice value 6. So 1 times 2 times 3 equals 6. We could also do this as a recursive problem. Just like before, we need some kind of break that says, hey, we're done. So we'd say if n equals 1, let's just return 1. If it doesn't equal 1, then what we want to do is we want to return the factorial of n minus 1. Yeah, the factorial of n minus 1 times n. That's what I want to do. So we take the value we have and we multiply it times a factorial of n minus 1. So if our value is 3, we're going to multiply that times a factorial of 2. And we take 2, we multiply that times a factorial of 1. Well, 1 is 1, so you're multiplying 1 times 2 and then back again to 3. And so if we take out this part right here, now we have the same code in factorial using recursion, and it just goes right down the list right there. And if we run this, we'll get the same value 6, just like we expected. And I want to go back a step. Let's just real quickly go back to here. There we go. For I in range of 1, f equals, we did the f times equals f, or I. So we're going through here, and this one looks pretty good. We've gone through, and it adds up the factorial. But as a recursion problem, if you remember correctly, this one just goes to the end. We know the exact answer. Danger of the recursion one, as we go back here and do a quick undo, is it's calling itself. And you can see right here if n equals 1, and then just keeps going minus 1 and minus 1, and if I run this, we get our 6. But what if the value in here is minus 3? Well, we keep subtracting. We go minus 3, minus 4, and so on. You can already see there's going to be a problem. And if I run this, it will crash the program because it gets stuck in a recursive loop. And here you go. It gives me the recursive error, maximum recursive depth exceeded in comparison. So we actually have a limit on there. So you got to be real careful with your recursive functions, but they're also really useful and handy in a lot of different scripting and computations. I hate to wrap up on an error, so I'll switch it back to 3 and run it, so we'll have our nice value of 6. What we want to talk about next, lambda. Lambda is a very useful tool, and especially when we get into what they call mapping and reducing functions. Map and reduce itself is a Hadoop term, and there's an actual scripting code called MapReduce, but it's also a programming way of thinking. So this is a very important concept, or a number of important concepts we're going to cover with the lambda, which means function. Lambda just is they call it the lambda function. And how and why it works and how it's used. What we're going to do is we're going to take our add function from before. We had add AB, very simple function to do. We have s equals a plus b return. If I run this, it'll add the 10 plus 20 on there. 30, just like you would expect it from our previous definitions. The lambda function, or its basis, is it actually does all of this in one line of code. So that's the first thing we're going to start with, is our very basic lambda function. L equals lambda. There's our keyword lambda, meaning it's a function. A comma b, and we get a plus b. And so when you see this, our lambda function, I can print L, and then we can do 10, 20. This does exactly what we just did with the add function. It takes the 10 and the 20. It comes across as a tuple. There's our tuple being sent in. The tuple is AB, and then it simply returns A plus B, whatever's on the right-hand side. So the lambda is a simple function. Now, it can get really complicated by using a function for the function, but you can just put your simple function here, A plus B, L equals lambda, A comma B, colon, A plus B, and we get our nice print L for lambda 1020. We can also do some kind of filtering in here. So let's create ourselves a list. Here's a list of letters. And let's say I want to take this list and I want to filter it out. So we'll give it a variable here for our lambda. We'll just use X. X is very commonly used in lambda. And then we'll put over here X in. And let's say, if you remember from before when we did the vowels, we had our A, E, I, O, U. And if we run this and I go ahead and print L, pop that back in there and run. Forgot we're doing a filter function. I forgot the whole of it. We're going to do a list, and we're going to do this list of a filter. So we'll need brackets for the list. I'll have my filter, and then I'll need brackets for the filter, what's going into the filter. And the filter comes in here. We're going to put the lambda in there. So let's break this down. I'm creating a list. From that list, I'm filtering out, and I'm going to use the lambda function. And the lambda function says, hey, for each entity in this list, I want to know if X is in A-E-I-O-U. And if it is in A-E-I-O-U, then at that point, I want to go ahead and add it to my list. And so here we go, we're adding it on to the LST, over filtering the LST, and we're returning the value to go into this list. What you can do is you could imagine that instead of this being a list of these, it might be a row in your database you're processing. So you have a lot of data coming in. And you can see right here, it filters it out, it gets rid of the B and the F, and we end up with our A-E-O-A. It filters it out. So imagine that you're sending it a row in your database. So for each row, we want to know what the lambda is, and it processes each character in this data. This could easily be an array or columns. You know, from your row, we might have column A, name, first name, last name, address, and you want to know which one of these is part of something else. So we've covered filter. What I want to cover next is mapping. And a lot of times when I work with filters and maps, and I'm working with data, the terminology map, when you're thinking map, is everything you can do to one line or one row in your database. You don't need all the other rows to look at it. So mapping is another tool, and the actual use of map with lambda, we'll do a result equals map lambda, and then we're going to take each character in there and we're going to just go we're going to convert it to its ASCII code, and we're going to add 1 to it. So we're just going to adjust it to each one. And so I forgot and took out my actual list. Of course, Pycharm already remembers it unless I restart the Pycharm environment. So it'd still work if I ran it. So we have our list A, B, E, F, O, A. And then we're going to get a result. Let's go ahead and print the result and run it. And you can see right here, result. And we'll convert it into a list. And so when we print the result, we get B, C, F, G, P, B. I'm guessing, A, the next one up would be B. B, the next one up would be C. E, the next one up would be F, and so on. And again, when we're talking about maps, the mapping part of a program, it's whatever you can do on one line of data. And I bring that up, and I keep saying that over and over and over again, because when you touch upon data processing, and especially big data, this is how we're able to cover tera and terabytes of data, is we process one row at a time. And that's the mapping. They call that is literally the mapping. We are mapping something. If I look at this row of data, I don't need to know anything else about the database other than this row of data. And that's how I'm going to map it. And if you're going to map something, you need to go ahead and reduce it, because if you have a ton of different rows in a database or whatever you're working with, in this case we're just working with characters in a list, you want to reduce it to something everybody can read, something you can process at a glance. We do need to go ahead and import reduce, so we'll do that from the function tools, import reduce. That makes it much more legible instead of doing functools.reduce. And then we'll do our results equals reduce lambda x of y, x plus y of our list. And all we're saying here is for each element that we look at, we're going to divide this up, and then we're just going to keep adding it on to our list. And then if we print out the result, we run it, you'll see we end up with A, B, E, F, O, A. And that's from the original list. Remember, this lambda result is not fed into here. This is the list that's being fed into here. In fact, let's go ahead and remove the map. I'm going to keep the map up there and reduce. So we mapped it, and then we so we're processing each individual character in our map. We're processing each individual character in this list changing it, tacking it onto the list so it returns the differences, and then we're going to bring them all together. So we're doing a reduction, reducing it into one string down here. So we've covered a lot. We've had our functions. We looked at our lambda. The next thing we want to look at is modules. And we've already been looking at that without even knowing it. And we'll start with, I'm going to call this, I renamed this one mod1.py. This is stuff we already did earlier. So we had our prime of a, our even number of a, def prime of a equals for I in range 2, comma a. If the remainder of a divided by I equals 0, print number is not prime, return number is prime. And then we also did even, print number is even, print number is odd. So this is something we did earlier. We created these definitions to let us know whether it's even or odd. I've changed the name to mod1.py, and this is going to be saved in the same folder as our Scratch. So this script that I'm going to write in here is in the same folder. You can also put it in your library. So if you have your environment and you have all your library folders, which has all the other default Python, including the modules we imported, this will access either one. And what we can simply do on this is we can now import our mod1. And so we can do from mod1 import everything. So that's going to import our two definitions. It's going to import prime and it's going to import even. And so anything we do in here can now access that. So we can now do n equals integer. Let's do an enter input and enter number. So we're going to have it input a number and it's going to force it to be an integer. So now we have our n and we'll simply do print. And let's take a look over here. We had from our module, we had print prime of a or even of a. Those are our two options on there. That's what we have brought in. So I can do print prime, and we're going to send n back there. And I can also do print, or actually there's no print because there's no return statement. So it's just prime of n and even of n. So those are the two things we imported. And if we run that, it's going to ask me to enter a number. We'll enter in 3 or 23 in this case, and you'll say number is prime, number is odd. So 23 is a prime number, and it's also an odd number. Is it even or odd? This could be very complicated because you could also do, add a select in here, run this if I have a selection of A or B or whatever. But at this point, you're now writing modules for your script. And you can see how you can easily organize a very lengthy program by having your different modules built outside of what you're working on. So you don't have this huge length of like hundreds of lines of code to read through. You only have the little piece you're working on. And you can share these modules. That way, if you're working as a group, just like we imported math, or NumPy is NP, we can now share these modules with other people who can then utilize them for their projects. Let's go ahead and close out of this and clear up my area I'm working with. And we're going to jump into the next big topic. That is not meaning that I just knocked my coffee over and spilled it all over my desk, but object-oriented programming. And we're going to start with the theory, because there's a lot of theory behind OOPS. It's been around since the 90s, very central to just about any programming language out there. And earlier when I pointed out that your functions, when we do the def statement, def whatever your function name is, that those are objects. We can actually set them to variables. And so object-oriented programming is what this is all centered on. We have an object. Everything in Python is an object if you look at it. Programming paradigm that focuses on objects. Every instance in Python is an object. So like I just said, everything you do in Python, you have an object you're looking at. An object has attributes, so we have data that's describing the object, and it has behavior, methods on the attributes. These are your definitions, your functions. And your attributes are your list, your arrays, your NumPy array, your variables. All those are attributes. And so, for example, if we have a BMW, I don't drive a BMW myself. I actually have a beatable pickup truck. Given where I live, I would prefer my pickup truck to the BMW, but if I live someplace else, I would definitely like a nice BMW to drive around. So for an example, you have year, manufacturer, maximum speed. Those are all attributes of your BMW. And for behavior, you might display the speed, because the speed's always changing. So there you go. Those are all behavior. As you accelerate, the amount of gas going into the engine changes. As you push on the brake, you're pushing on the brake is a behavior and it's changing the speed of the car. So we define a class class is a collection of similar objects. So for example, a car, we have BMW, we have Ford, we have an Audi. The inheritance mechanism for a new class to use the features of another class. So we have a number of different things. Inheritance, we might have our class which is vehicles, and then under vehicles we might have cars. And cars inherits all the different stuff from vehicles. So we have inheritance, so you can create a class from another class. The feature preventing data from direct access is called encapsulation. So when we have our object programming, we have integers. We looked at integers. You can't actually access integer. You assign a variable that has all the different features and functions of an integer, but you don't access the actual integer object. You can, but generally you don't. You have it encapsulated so that it's never altered. And polymorphism is a feature of using the same function in multiple ways. So you can think of this in our example of vehicles and cars. We might also have vehicles and bicycles. Well, bicycles accelerate very different than a car does. A car, you step on the gas. A bicycle, you step on the pedal. Both of them have a similar acceleration. You want to polymorph that function so that it works the same for both of those, but it does something very different. So let's go ahead and create our class, and we'll call it car. We have our semicolon here, which says that whatever comes after this is indented as part of the class car. Now there's some things we're leaving out here. You'll almost always see brackets and variables in there. We'll look at that in just a moment. Let's just start with the class car. And we might have car type. Let's give it an attribute. And this particular attribute is a car type, and we'll set it equal to manual. And this is a global variable we've set up on here that's used throughout the setup, throughout the class car. And then we want to create a def. And this is a very special definition. Remember, that's a function for def, and we call it init. It stands for initialize, and we put a double underscore before it and a double underscore after it. What that means is when I create this class, an instance of the class, not the class itself, but I create this instance of this class, I create a variable equal to car. This initializes it, and self means that it's referring to itself. Whenever you see self in the class, you're referring to that instance. And we'll look at that a little bit more closer in just a minute, so hopefully if you're confused, we'll be able to help you with that. We'll go ahead and pass it a couple variables. Speed, so when we initiate class, we're going to pass it year and speed, and then self is just part of what's passed into the definition. And we'll go ahead and do self.year equals year, and self.speed equals speed. So up here we have a global variable, and down here we have an instance feature. I use variable and feature kind of interchangeably, but certainly feature is probably the more appropriate word, but they are variables also. Either way, they're the same thing. And then let's go ahead and create what's called a static method. And you set it that by doing the @ symbol here, and we'll call it static method. This is a command. It lets us know that this is not specific to an object or the class's variable. So this is independent of our specific initiation. And with this, we're going to do welcome, and we'll just have it do a print down here. We'll go print, welcome to the car showroom. Kind of fun there. So here's our, oops, I forgot to put the def in front of welcome. This is tabbed in. So when we do this, when I have our instance, this never changes. It's a static method. It's always going to do the same thing. It doesn't matter where it's coming from. It doesn't need to access any other information any other features in the class car or in whatever initiated variable I have. And then we'll do something a little bit more traditional. Def get speed. It automatically does the self. And in this case, we're just going to do print maximum speed is self.speed. Now remember, we initiated it. So here's our self.speed. Self means it's the instance we're creating. It's not the actual class, but the instance. And we're going to print that out. And so let's take a look at that and just see how this all comes together. I did forget one piece of the puzzle. Just like we have a static method, I'm going to do this up here. We also have what's called class specific. So when you have a class specific method, you denote that with class method. Now remember, the static method doesn't care anything about what's in the class. It doesn't care about the initiation. It has all the information it needs. With the class method, we need to go ahead and have information that's class specific. And we did that up here when I did class and I did car type equals manual. So that's the feature that we can access underneath this title. And we'll create a definition here, and we'll call this type. We'll just do CLS. because it's a class method. That's what the CLS stands for. And then we're going to do print. We're in a nice showroom, and we say these cars are, comma, CLS.car type. So the CLS just refers to the class. Class are variables without the self in front. So when I have a class or a feature underneath class, any instance I create is going to have car type equals manual. Where when I initiate it and I have self, any feature like self.year, self.speed is going to be just that instance has that feature and whatever value we put into it. And then we have a static method which only accesses the static method. It doesn't have any other information coming into it from either the class or external. And then you can see here we have type class, denoted by CLS, and we can print the class type. And then we have the self. There's our self, our most basic definition, get speed. And the way this works is we have our let's do our, here's our BMW. So our BMW equals, make sure there's no spaces in front of it. It's going to equal car, and we have our car class. Back up here, yeah, I did it all lowercase. A lot of times the classes you want to start with a capital letter. You don't have to, but that just is like a kind of a programmer standard on there. So you can remember that it is a class versus a variable, which we start with lowercase. And if you go up here to initial, we have self, which it automatically sends, because this is a part of the car, and then we have year and speed. And so we want to go ahead and send those in there. We're going to do 2018, and we'll say it has a maximum speed of 155. I don't usually, living where I do, I don't go over 75 or 80 at the tops due to the particular laws we have. And we'll do a Ford, and this particular Ford on their showroom, what, a 2016. And maybe our Ford has a maximum speed of 140. So now we've created two instances. And if I do bmw.getSpeed, you'll see here that it doesn't, the self, which I put in here, isn't needed because it already pulls the self in. That is the instance. It's saying the BMW, which I called it, is pulling in BMW on here. And all the features with self are pulled into it also. So if I run this, you'll see down here that it pulls up the speed. It says maximum speed is 155 for our BMW. And let's say we want to know about the Ford. Maybe we'll do Ford get speed, and we run this, and the maximum speed for the Ford is 140. And of course we're looking at the little ticker tape of the car, and along comes the guy who says, hey, do you want to buy a car? And we'll do the car welcome. And if we run that, it says, messed up on this because it's a capital C. There we go. And we do the car welcome, and it says, welcome to the car showroom. Maximum speed is 140 on the car you're looking at. Our salesman's come up and approached us. And then finally, we might be looking around the showroom and saying, hey, what kind of showroom is this? What are you guys showing to me? We can do car type. We see that it comes up, these cares, typo there. These cars are, and then it looks at the car type and says manual. So you're in the manual car showroom. Now, this is all great. You have your class car. Let me go ahead and just get rid of some of this stuff. Take it back a notch, clean it up, take out, keep our BMW and Ford down there. And so with our class car, we now have under there an init. We'll keep the init where we put in the year and the speed, and we set that. I've taken out my static method, but I do want to add in, let's go back and put the get speed back in, self. Get speed, and we'll just print like we had before, maximum speed. And because we put it in as for the instance, we'll do self.speed. That's how we reference it there. So right now we have our basic class car, and that looks pretty good. But what if we're talking about, remember we had like these models are all standard, these models are all whatever. What if I want to have a class sedan? So we're looking at just sedans. But I wanted to have all the features of the car. I don't want to have to do a economy, a sedan, a four-wheel drive. I don't want to redo all of the work I do in car because the get speed's going to be the same, the year and everything else is going to be the same. What I can do is we can do an inheritance. And that means when I do a class sedan of car, this inherit everything from car. So everything I have above in car is inherited. So any instance I create of sedan uses all the values in car. And we can change some things on here, but let me just show you how this works to begin with. Instead of doing, I can do this part right here. Let me just do bmw.getSpeed. So I still have my car class. So if I run this, you will see indent error because I forgot. I created this here. Let's go. Pass is just a fancy way of putting a placeholder here saying the code is here, but don't do anything. So I processed maximum speed is 155. And what happens instead of a car, we do a sedan and we run this, I still get maximum speed is 155. Well, sedan doesn't have that in there, but sedan inherited everything from car. So when we look at this, I have maximum speed equals self.speed. And the initialization is the same, self.year, self.speed on there. Now, we can also do something like this with sedan. I can copy all this over. Generally, you don't just do a pass here. At the very least, you need your init file in this. And so here's my initialization. And so with sedan, we're going to do something like this. I'm going to go super.init year, speed. And what I'm telling it is it comes in and it says, okay, I'm initializing a sedan. This is my initialization code. But we're going to go to the class that this inherited from, which is our car, and we're going to do the init there. This basically comes up here and says, okay, this is our init. This is how we're going to initialize this. But in addition to that, what I want to do is I also want to do something like this. Print this is a sedan. And so now when I run this, our BMW initializes as a sedan. It does the super, so it uses all of the init code underneath our class car. And then in addition to that, it's whatever I want to do. In this case, I want to just print this is a sedan. So you can see it prints this is a sedan. And then when I run get speed, it still utilizes that from the original class. So now I also have the speed and the initialization all under my original class car. I'm not recreating it and retyping it, copying it down there. And just like we have defs up here under class, we might have certain definitions which are very specific to the sedan. So maybe we have open trunk. So we'll put that in there. There's our definition for open trunk. And all it does is print open trunk. And so I can do BMW dot open trunk. And if I run this, my BMW now can open the trunk. So now it has additional functionality that cars doesn't. We can see this if I do for.open trunk. And if you guessed it, it'd give us a error. You're correct. Car doesn't have an open trunk. I'm sorry, it's an error. This Ford, maybe it's a Ford truck, it doesn't have a trunk, so it can't open it. So this is only if it's a sedan does it have open trunk underneath of it. And this, being able to add new definitions is our polymorphism. We can polymorph our class to do things the original class couldn't do. And we can go ahead, we could take this, let's change this up a little bit here. We'll initialize this with name, and then self.name equals name. And instead of setting the speeds here, we'll just say that this particular individual car, maximum speed of 150 for get speed, and we'll do the same thing down here. We'll have instead of a sedan, let's do this. Let's just take this completely out of here. We'll take our sedan, and the sedan will have a speed of 150. But instead of a sedan, that works. We'll just do sedan. And then maybe we'll also have another one that is an SUV. And so our SUV class, they all have a maximum speed of 120. Name this SUV. And so now that we have these two classes, they're both inheriting from cars. So when we send something to them, we're going to send name, self.name, and then we have def get speed, which is going to return 150. Class SUV, maximum speed is 120. So we're storing the name underneath each instance of it, and then we're also going to get a different speed each time. Let's do a list. We'll do a car list. Here's our list of cars. There's our brackets for our list, and then I'm going to do something kind of fun here. Here's a sedan. Now, the sedan is the class. So that's an object. So I can make a list of that object. And in that particular object, we're going to give it a name. And the name of this one is going to be, it's a Camry, very common car out there. And then I'm going to create a second object, and it's going to be an SUV class. Now remember, we also did variables as definitions. Certainly you can put anything that's an object into a variable. So these are a list of classes on here with their calls. And the SUV, we're going to do, I guess, Scorpio. I'm not too familiar with the Scorpio car, but I guess it's one of the common SUVs in certain areas. So now I have a list of two classes, and these classes are both initialized, the first one with Camry and with Scorpio. And from before, we can do for car and car list. So we're going to do each car, and then we're just going to do something simple like print, in this case, car.name. And kind of a fun one, we'll add the plus sign in, and the brackets, and the colon, and give me just a second to put this together, comma end equals double brackets. This is basically, we're telling it don't print a new line. I want to print the car followed by car.accelerate. So remember we did get speed, so we'll stick with get speed. Control copy. Get speed. Put in our double brackets. I'm just going to add a space up here and here. Oops, actually goes at the beginning. So if I run this, it should go all the way through this list. Here's our for loop. Remember this, how we talked about iterating through a list of objects. There's our car list. And as we go through, we see Scorpio. We have our Camry. Camry is maximum speed 150. Scorpio, maximum speed 120. So we put together a nice set of polymorphism of classes. We polymorphed our car class into a sedan and into an SUV, so they each print out a very different thing or have a very different get speed functionality. But they both inherit the initial def from car. So we've covered a lot today. We've covered a lot across the spectrum on some basic Python, from variables. We talked about lists, sets, tuples. We talked about arrays and NumPy arrays. We talked about truth functions and operators, math functions, input. We talked about the if-else and our true-false logic, our while loop, our for loop, break, continue. We talked about functions with our args, started by an asterisk or a double asterisk for KW args. We talked about recursion in our definitions and functions. We discussed lambda, touched a little bit on map and reduce. Then we looked at modules, how you can create your own modules in the framework. And we also covered object-oriented programming concepts and classes, initialization, along with inheritance, encapsulation, and polymorphism. So we covered a lot today. I want to thank you for joining me. Hopefully we'll have a part 2 of this, which you can follow up, along with many of our other great tutorials that we put out. For more information, visit www.simplilearn.com. Again, my name is Richard Kirshner with the Simplilearn team. That is www.simplilearn.com. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.